All right, I always get a lot of questions on the equations of motions lab. So what I want to do is just do kind of a short introduction to this. And so a couple things to kind of help you out as you do this lab and just maybe get you started, okay? So here's our lab simulator. It's the equations of motions lab. And we also should have pulled up our graphing simulator. Now this can be found under the link on Canvas there where you downloaded the lab. It can also be found, not right here, let's actually look at the lab itself. There's a link right here where you can open up, I'm sorry, this is the program for the Equations of Motions lab. You're going to have to go to Canvas to come up with the graphing simulator. So in Canvas, you'll see that graphing simulator there. If you have any questions on how to get that, let me know. So going through the directions here, it says, okay, if you got a desktop, use the desktop. If you have a tablet, use touch. So whatever you're using there. Use the down arrow. This is step 3. Use the down arrow to set the car's acceleration at 0 meters per second, and then you pick a speed. Okay, so let's do that first. So this is what they mean by the down arrow. We're going to set that to 0, and then we're going to pick an initial speed, whatever you're going to set it to. I'm going to do not 0, but 4 meters per second, okay? Now it said in the directions that you have to use the speed for what? This section of the lab. So keep it for this section. So then it says in the data table below with the time traveled on the x-axis and the distance that you cover on the y-axis, and then push and hold down on the gas pedal for a short period of time. Notice when you stop pushing on the accelerator, a car's shadow appears. So this is where they stop pushing on the accelerator. And then the car keeps moving at a constant velocity, okay? Record the time accelerating in your data table. This is found on the right side of the web page. So let's take a look at that. Let's do one of these. I've got it set to 4, and we're going to tell this thing to go. So I'm going to push the gas pedal here, and I'm going to go, 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 go. And then I'm going to stop right there. Now, I just kind of chose that randomly. It tells me the time spent accelerating was 4, and that's what I'm going to record on my initial, or on my data table. So where's that data table? Let's pull that up. All the way down here. So trial number 1, I have my X time and my Y distance. So I'm going to put those in there. So go back to the simulator here, and we notice, all right, how long did I, or for what distance did I accelerate it? And this looks like right here is 15, I'd say about 16, and we can estimate one past that. 16.1 is my distance. So when I go to put this in, I'm going to type in 16.1. 16, I got to enable editing here. There we go. Whoops. Now we can do it. 16.1. Nope. Sometimes Microsoft Word just doesn't want to cooperate, right? 16.1, and this is in meters. And then, sorry, that's my distance. That's going to go in my Y value. I promise I can do this. Let's cut that out. It goes in the Y box. Notice in the X box it says the distance. So let's go back and look at that. Sorry, the time. The time here is 4 seconds. So I'm going to travel back and put in 4 seconds right here. You're going to do this again for 5 trials. So let's do a second one here together, and then I'll fill out the rest on my own. So I'm going to reset this, and this time I just want to do it for a different distance. So right there. So I did a little bit shorter this time, and let's see, this went about, I'd say 8 meters exactly in 2 seconds. So 8 meters, 2 seconds, that's what I'm going to type in right here. We took 2 seconds, and we went 8 meters, or we say 8.0 meters. Let us know that we did estimate that to the nearest tenth. It was just right on the money. Now I'm going to pause the recording and do 3 more trials just like that to get some data. All right, so now we're looking at my data filled out here. I do want to point out a couple of things. When I collected this data, I just didn't do everything under 10 meters because we're going to graph this, and we want a nice good set of data. So some large numbers and small numbers because we want to do a line of best fit. So the first one, as we did together, we did 16.1 meters. The next one was 8 meters. So we had one below 10, one between 10 and 20. I chose one right here around 20, then in the 30s, then in the 50s. I did this so that we can get just a nice good picture of what's going on with our data. All right, so that way it's not something that's super linear, that shouldn't be linear, but maybe this thing kind of curves out, and I believe it will. We'll see though, maybe it won't. And we have our time written right here. It is always important to make sure we're paying attention to what's being thrown up here in the X column, what's being thrown in the Y column. As you saw in the beginning there, I start to put meters there and I said, wait a minute, that says time. You could also change this so that it actually has like the units up here. If you don't want to put units in the chart, you could put units up here in the title. And sometimes that's easier when we're copying and pasting it in different programs. So we've got that said. We are all filled out there. Record the time accelerating, record the distance, and then we did this 5 times. Our chart's filled out there. Now it says, using the data table, construct a graph of your data. You can use the graphing program introduced to you earlier in class. The link is found in the lesson, right? The graphs equation and all that good stuff. So let's go ahead and start with that right there. We're going to switch now to the graphing program. And again, that is linked into the Canvas assignment. I'm actually going to try to split screen this. Actually, no, I'm not. What I'm doing instead is I'm just going to fill out this chart. I'm going to pause the video, fill out this chart. So this could be my X column again, my Y column, and then we'll come back. All right, I just want to show you how I do this because it might save you a little bit of going back and forth between tabs. I like to kind of split screen it where you take and actually just drag over and it snaps, and then you can pick like which one you want on the right side and the left side, and that way I can just copy over the data without doing a whole lot. Now I'm going to switch this back to just full screen mode. I've put these in here, notice without the units because we are actually graphing it in here. And so we've got this thing where it says X, the thing you change, and Y, the dependent variable. I'm going to change this to what we're actually dealing with here so it shows up on my graph correctly. So I'm going to say this is the distance, and I'm going to say, hey, this is in meters. Notice it should change things up. Let's thing right here. Let's do time, and this is in seconds. Now notice my X and my Y axis are already labeled correctly for me. It's not saying X, the thing you change, and Y and all that. This is actually showing up correct. This is good graphing right here. It's automatically scaled for me. And then we've got a title of the graph saying distance versus time. Remember, every time we see a graph labeled in physics and it says something versus something, this first part, distance, must be on my y-axis. The second part goes on the x-axis. So I can immediately see in the title what should be on the x and y-axis, but the x and y-axis are labeled. And because up here in the title I put what the units were, now everything is done correctly. And we can kind of see the dots from our data here already graphed out for us. Notice we do not have an equation. That would be down here where it says data set 1. So I'm going to do a curve fit. I'm going to click on that curve fit. What does this look like to you? Well, to me, it looks linear. So it's going to do a line of best fit through there in the linear section. And this gives me a data set right here. If we think back to the equations this might relate to, it would be something like final velocity equals initial velocity plus acceleration times delta t. That's 1. So I'm thinking that's kind of linear. And so that kind of makes sense that this would be linear. Or you could say, hey, final velocity squared equals initial velocity squared plus 2a delta x. So we're going to see a linear relationship there as well. All right, so now that we got our line of best fit in our data, we want to enter in this graph into our document. Now, the easiest way is probably just hit right click and hit copy image, or probably copy image and then paste it, but then it kind of becomes a pain trying to make it look nice in the actual lab report because it's Microsoft Word and it pushes things everywhere and you got to play around with it. I find the easiest way is to pull up the snippet tool. Now what the snippet tool does, I've already kind of done this one time, but I'm going to show you like as if we haven't done it already. I'm going to hit new snippet and I get to drag and select. Nope, not like that. I need to select the whole thing. See how it selects part of it? Let's drag and select the whole area right here. We have distance and time. Notice what I'm doing is I've got my X and my Y-axis label plus the graph and the title of the graph. All of that's being snipped. So that's what it just copied to the clipboard on your computer. Now, if you don't have like a, what do you call it, a Windows PC, you might have to look up how to do this on a Mac, but a Mac has a similar tools. I'm just not as familiar with those. And right here's where we're going to hit, hey, let's paste this in. So Control V will paste that in. And now this is set up so that the teacher can read this. I can see where you got the distance, the time, and I can see where you've done that. All right, it matches your data on your data table there. And my Mouse pad keeps zooming in by accident. There we go. Zoom out. What does the slope tell you about this graph? Well, if we notice, we can't really, you don't want to calculate the slope because it's already been calculated for you. That's the beauty of this program right here. Look at this. Your slope is right there, 3.287. Or you could just say, hey, I know that if I take distance, that's my rise, and divide it by my run, which is time right here, distance divided by time is velocity. So this is our velocity. Going back to the actual simulation, because we have the acceleration at 0, this is really just a constant speed through here. So it's a constant speed times time. That's why that works out. Now we got our speed here to be 4 meters per second. So we're a little bit off when we compare that to our graph here. So some other things that we could look at is, did we choose the wrong relationship here? This is linear, but it could have also been proportional. Now proportional gets a little bit closer to our velocity of 4. So probably one of my data points might be just a little bit off and throwing things off, but really it is our speed right here is the answer to that question. Then we're going to use the equation for your graph. How far will it travel in 2 minutes? So you're going to write out that equation right here. So once again, you could just say, like, you know, type it out from that. That's our equation right there. It's not too hard to type out. Let's go back to the linear relationship. The linear relationship, that's what it is right here. It's actually giving us, you know, it goes back here and say, hey, at 0 seconds, we were this distance away. So it's pulling it back. That's what throws off that slope. So it's probably one of these data points that's throwing off our line of best fit. If it's proportional, notice it goes through 0, it forces it through 0. And so our value comes a little bit better there. But that's our equation we can use. Sometimes these equations are super complicated. So you could, you know, if it's just asking for the equation, which I'm not here, but if I'm just asking for the equation, check that out. You can snip it right there as well and paste it into the document if that's what you need. But you should be able to answer that. You should be able to put this in and put 2 minutes, notice is 120 seconds. Put that in and calculate it out. I'm trying to scroll down and keep zooming in. And then we talk about distance there. You can plug that into the equation and calculate it out, and then talk about a relationship there. That's part 1. Pretty much worked out for you. You just got to get your own data. Don't use my data. Come up with some different data points here. But I think this is needed because a lot of students are questioning, like, hey, how do I put stuff into the document? How do I graph it? A lot of you, you know, you want to make sure you're using the graphing program just because it's so much easier and it's going to get you those easy points there instead of trying to do the graph like by drawing it out, you know, on a computer screen using your finger or whatever. It's just not going to have the data you need, and it's not going to have the X and Y axis labeled correctly. Okay? I hope that helps. Thanks for watching, and let me know if you have any questions. Have a great day.